In section 5.3, we're going to deal with exponential and logarithmic integrals. And so definition 5.3 tells us how to differentiate a function involving e to the x or e to the u. So I think we've already addressed this a little bit, that if you want to take the integral of e to the x, it's just going to be e to the x plus c, because the derivative of e to the x plus c is just e to the x. And then if you have a function u in terms of x, then you need to apply a u-substitution, and you should get something like e to the u plus c. So let's see this in action in example 5.9. So in this case, u is going to be equal to 3x, and then in that case, du should be equal to 3 dx. Okay, and that's because du dx equals 3, and then you can think of this as kind of a shorthand of just multiplying the other side, multiplying the dx on both sides to get du equals 3 dx. And then if you divide both sides by 3, you see that du over 3 must be equal to dx. Okay, and so what that's going to allow us to do is to substitute this with the du over 3 because they're equal, and we can substitute e to the 3x as e to the u because u is equal to 3x. So let's do the problem now. We have the integral of e to the 3x dx. That's going to be equal to the integral of e to the u times du over 3. And that's like du times 1/3. So then, just to make things look a little bit nicer, I always write the 1/3 out front of the integral. So this is 1/3 the integral of e to the u du. And then the integral of e to the u du will just be e to the u plus c. And then finally, you plug back in 3x for u. So you get 1/3 e to the 3x plus c. And now, if you wanted to, you could check. Maybe I'll do that right here. It's a good idea to check that if you take the derivative of e to the 3x over 3 plus c, you get, well, the derivative of the constant c is 0, and then the derivative of e to the 3x is going to be e to the 3x times 3 over 3, and so the 3 over 3 cancels, and you're left with e to the 3x. And that's just to check to make sure you took the integral correctly.